Who remembers, how do you take a whole number and change it to an improper fraction? Brody. Yep, that's the simplest way to do it. Put whatever that whole number is over 1. That's the improper fraction in what's called simplest form. What about 12? Francesca, let's raise our hand. Francesca, one more time. Jack Ferretti, 101. Hold on, let me fix this. One more time, Jack. Hayden. Okay, sound good? Now, LCD stands for lowest common. What's the D stand for? Very good. So our goal is to try to create two equivalent fractions that have the same denominator. Well, what should our common denominator be for 4 and 5? What's the lowest number that both 4 and 5 go into? Yes. Now, it's just like what we did in ratios. 5 times what makes 20? 4 times 2. Okay, so that's equivalent to 8/20ths. 4 times what makes 20? 5 times 3. That one's done. Can we scale 5/10ths down? What would 10 have to be divided by in order to get 5? 2, right? However, when you do 5 divided by 2, do you wind up with a number that's a whole number? So we can't scale this down. If you divide by 5, you're going to get a common denominator of 2. That doesn't help us. We have to make a 5, or in this case, we can't make a 5. We should make a what? Yes, we need to make a 10. 5 times what makes 10? 2 times 6. And this stays the same because it's a constant of 1. What about 4/6? Can you scale it down? It'll work this time, won't it? Because if I divide it by 2, I could do 4 divided by 2. What do you get?
2.
Hey, look at that. They're both equivalent fractions anyway to begin with. Okay? Let's move on. This is going to look similar to what we've been doing, but it's different. Maria has how much mix? Maria has how much mix? Say it nice and loud again. 3/4. Is that greater than 1, Lewis, or less than 1? It's less than 1 pound, right? She's got to divide that 3/4 to 6 different people. So is each person going to have greater than a pound or less than a pound? Less. It's going to be less than 3/4. Okay? Visualizes. This is Maria, right? Make a box around Maria. She has how much mix? She's got 3/4. She's got to divide it among how many people? 1, 2, 3, 4, 5, 6. Do a little spider here. This is a person. This is a person. This is a person. So forth. So she's got an amount that's less than 1 to begin with, and now she's got to divvy it up into even smaller portions. So no matter what, to figure out what this is it 3/4 divided by 6 or 6 divided by 3/4? What does she have? She's dividing that by 6. 3/4 divided by 6. Up to this point, we've had, I don't know if you can remember or not, we've had bigger number being divided by a smaller number. Now it's the other way around. We got smaller number being divided by a bigger number. The think statement doesn't change though. How many what and what? No. How many sixes are in 3/4? Always flip it. We've already said this, but will our answer be greater than 1 or less than 1? Will it be greater than or less than 3/4? Uh-oh. I'm starting with 3/4 and I'm divvying it up 6 more times. Less, right? Okay. Okay, so if we're going to do it as straight division, 3/4 divided by what? Over. Can we do it as is? What have we been doing? You had to do it in your exit ticket before you did your number line. Not if we're going to do number line. I'll show that to you in the very last step. If I'm going to use a number line, what do I have to do first? Jay? Can't hear you, bud. Not yet. Need a common denominator. You've got to convert at least one of these. Between 4 and 1, what should your common denominator be? I agree. In order to make 1 a 4, you got to multiply it by? Okay, so now I have still 3/4. There's not a whole lot of room here. Is there more room on your sheet? Because I don't remember. Okay, I need the equivalent fraction for 6/1 that has a denominator of 4. Eric? Yes, 6 times 4 gives us 24. How many what and what? Eric? Okay, good, you remembered. Okay, now comes the numbering. 0, what's our first fraction? Then what? Okay, now I'm going to ask you something. Tell me if this confuses you. Since they're all in fourths, I could cheat a little bit. Are you okay with me just numbering the tops since I know all the bottoms are the same? Because that's all we really need to do our leaps and our go-to anyway. We don't really use the bottom once we know what we're counting by. And it saves us a little bit of time. And if it works out perfectly and you've counted correctly, you should wind up with 24 exact lines. Now comes the most important question, I think. Where's my go-to? Jack, where's my go-to? James, where's my go-to? Where's my go-to? Remember when we put it in this, what's this? Except that fraction was wrong. In the think statement, where is the go-to always? No. Come on, guys. You got to put your brains together and think. Is it the first number or the second number that's always the go-to? That's something you got to know by now. We're all over the place.
It depends if you're looking at it from the expression, which is 3/4 divided by 24/4. Or are you looking at it from the think statement, which is the 24/4 in 3/4? So if you look from the main expression, what's the go-to number? 24. What's the go-to number?
The go-to. Once you guys, here's what you got to get into your head. Once you have the think statement, how many, what, and what, no matter what, the second number is always the go-to. That will never change. Always the go-to. That's my go. This is my leap. Can you leap? Do you have one full leap? Do you have one full leap? No! Which makes sense because you've already told us the answer's got to be less than 1. So you don't have one full leap. If you flip it and do it the wrong way, guess what? You're going to have 24 leaps, all right? You already told me if I've got 3/4 and I'm splitting it between 6 people, my answer has to be less than 3/4, which is less than 1, which is less than 1 full leap. This is my go-to. Leap by 24. Do I have a complete leap? My first leap is dotted. It's my only leap. How far is my destination within my leap? 1, 2, 3 out of? The answer is 3/24, which we can reduce to 1/8. That's the concept that makes this lesson different from what we've been doing, is that all of your answers, you'll not get one single leap with any of these. They're all going to be less than 1. Okay, let me show it to you using common denominators. I need to scroll up. It was 3/4 divided by 6, right? Yes? 3/4 divided by what was 6/1 with a common denominator of 4? 24/4. Ready? Do I have common denominators? If I go straight division now, which number's on the outside? 24 into 3. Ready? This is going to look really strange looking. 24 goes into 3 how many times? 0. How much left over? 0, with 3 left over out of 24. 3/24, final answer. Keep, change, flip. Ready? Reciprocal fraction shortcut is KCF. 3/4 divided by 6. Ready? What gets kept the same? What gets kept the same? Yes. Change division to 6/1 becomes what? 3 times 1, everybody. 4 times 6, everybody. Magic. Okay. Okay, turn. Mrs. Singleton is making her network debut. Everybody give her a round of applause.
All right, guys, let's take a look at example 2. Okay, so same idea, different example, okay? It says, imagine that you have 2/5 of a cup of frosting that you need to share equally between 3 desserts. How much frosting does each dessert get? What do you have? Okay, so let's just make ourselves a note. This is what you have. And you need to share it equally between 3 desserts. How much frosting does each one get? So what is our expression?
Meaning, how do I write this? What is it going to look like, Alexa? You start with what you have. Okay, so it's going to be 2/5 divided by what? 3, because 3 is the number of desserts that you need to share it equally through. Does that make sense? Okay, so now we need to write our think statement. If this is our expression, the question becomes how many what in what? How many 3s can we get into 2/5? And we told you that this lesson, the numbers are going to be greater than 1 or less than 1. So it's going to be less than. When you find a common denominator, you need to first write your original expression, which is 2/5 divided by 3. However, 3 is a whole number, and I need to make it into a fraction. And how do I do that, Louis? What happens to the 3? How do I get a whole number as a fraction? Correct. Going back to the beginning lesson of 1, can I divide this? No, because I need like denominators. So I need to get a number that 5 and 1 have in common. What could I use? I could use 5. Are we good so far? If I look at my first fraction, did I change anything? I did not, so I'm going to leave it as I see it. However, what do I do to go from 1 to 5? Whatever I do to the bottom, I must. 3 times 5. So now I'm going to ask myself what? How many
15/5 are 2/5.
Okay. Again, the number line, I'm counting out of how many? What's my denominator again? 5s. Okay, I'm counting out of 5. So it's 1/5, 2/5, 3/5, all the way. This is where you're going to see 2 different methods. Mr. Alessi has presented it to you as when you have your think statement, which is what F is. It's a think statement. He is telling you the second number is your go-to number. And the first number becomes how you, thank you, that's your leap, okay? Now, this is not meant to confuse you. However, this is kind of my thought process. You take your original division expression, and I'm very visual, so I look at it through the alphabet. Go and leap. Go to and leap. This works only when you use your original expression. it does not make a difference which method you use. If you use the go-to, if you use the think statement, the second fraction is the go-to. Do you see it two different ways?
It never changes.
Exactly.
No matter what.
Okay, so if that's my go-to, I like to say I'm going to build the wall. There's my wall. 2/5, right? And how am I leaping? By 15. So my thing is, okay, here I go. I'm jumping, and guess what I did? I hit the wall. But I can keep going to 15. That's my dotted line, because that's how I have to leap. But I hit the wall at 2. So how am I leaping? How am I leaping? I'm leaping by 15. How far did I leap before I hit the wall? Do you see that? Again, if you were to use this using a common denominator, you're going to take your original problem and then you rewrite it. You get your common denominator, which you already have. Now remember, when you go across, which number goes inside the house? It's getting rained on. The first number is getting rained on. So it becomes this. Right? Can 15 go into 2? Nope. 2/15. That's your common denominator way. If we use reciprocal, Kentucky chicken fried, you're going to take your original and you're going to write, I'm going to keep, change, flip my fraction. Keep the first fraction the same. I change my operation to multiplication. And instead of 3/1, it becomes 1/3. Now I multiply across. 2 times 1 is 2. 5 times 3 is 15. Check. Do you see it? Perfect.